So today we're changing a chain ring. It's going to be this middle chain ring. What's been happening is I've been having a lot of slip. Feels like I'm breaking a chain while climbing, but it's these teeth that are worn out. Let's go on the other side and give you a peek on what it looks like on the other side. Maybe it's a bit clearer. There's some good teeth in there, and right here we can see that one's about half, and that one's half as well. Half of the height it should be nice and sharp like these other teeth on the other chain rings. This whole region right here is all worn down. Right here. Yeah, these are all smoothed out. It might as well be non-existent, and that's been causing me to slip under high torque on climbing mountains here. That tooth is what it should look like, and this one's what it should. So it's a bit odd. You've got some really good teeth in there, and then you've got some that look like they've been sheared away, but when looking close it looks like it's just been worn down. Some more worn teeth. And right here you can see it's gonna be a 104mm by 32 teeth and a 4 bolt pattern. This one's made by FSA. It's the original manufacturer of the crank set, so I'm just getting a direct replacement here. So we'll start by taking off the crank arm on the non-drive side. This is the side without the chain. It's held on by a 5mm Allen key. Well, we're going to use a 5mm Allen key to take off this center crank arm bolt. That's going to provide tension later on when we reinstall it. That's what the bolt looks like. And then it's held on by 2 Allen bolts, one on each side. So we'll start with this one that is here on the top. And there it is. It's going to be that inner one. All we want to do is back them out. We don't really want to take them fully out. I just like to keep bolts where they are. It's not going to prevent us from taking out the crank arm completely. It's just providing a clamping force. So we just back them out enough to give the spline some room to wiggle out, and then here's the other one on the other side. So we're just going to back this one out until it feels loose, and then give it a couple of turns to engage in the thread again, so then we don't lose the bolts. I'm just using a screwdriver to loosen what 5 years of clamping force will do. And those are the splines that hold everything together. Remove the chain. And just moderate force should slip the entire crank set out from the bottom bracket. Just a little wiggling here. And some moderate force. And this is what the crank set looks like. And this is the Torx bit we're going to be using. It's a 27 Torx bit. Goes on the end of a socket wrench and or Allen. Still the 5mm. So right now we're just removing the 4 chainring bolt sets. It's going to be a bolt in the front and a nut kind of deal in the back. You can see right there it's a smoothed exterior nut, and it's like a male and a female nut and bolt set. There's going to be 4 of them holding in our chainring. And for our chainring, it's the same 4 bolts that are gonna hold the outer ring and the middle ring. Those are the 2 that we want to get out. And you can see the inner chain ring, the smallest one, that's got its own 4 bolts. We're not going to touch those today. Now that we've got all the chainring bolts loose and out, we can remove the 2 inner and the middle and the outer chainring. That's the middle one and the larger chainring. So this is our new chainring replacement. That's going to be the new for the middle. That's the one that we use, well, for me, that's the one I use the most. Mostly everyone uses this most as well. Yeah, $23 on Amazon. Just comparing the 2. On this side they look about the same. On this side it's a little bit different. It's got a little bit of shiny, not so much polish, but machined. So I just want to make sure the bolts line up properly so that I'm not going to have any problems when I'm putting it in. And just seeing what the orientation is like, and it looks like a direct fit, exact size. So you just want to know what the diameter is, the 104mm, and also the how many teeth you've got on there. Mine said 32 teeth. So I just want to test fit everything, make sure everything is gonna go on smoothly before I actually bolt it all up. Just want to get the orientation correct as well. Can just line up the logos. The outer chainring is going to be slipped on from the pedal side of the crankset. So the tabs for the crank arms have recesses for the outer chainring, that's the large chainring, and the middle chainring. Just want to line this all up to make sure we've got the orientation correct and see how everything is going to go together. It's a good idea to test fit. And that looks about right there. So what I'm going to do is I'm just going to loosely insert all 4 of the chain ring bolt sets. That's the backside nut, backside female nut, and it's going to be the front side male bolt of this chain ring bolt set. So now that we've got all the chainring bolt sets in, the back side is going to be where I'm going to use the 5mm Allen key, and the front side is where I'm using the 27 Torx bit. Funny thing is, one of my bolt sets is 5mm Allen, 5mm Allen. Don't ask, don't know where that came from. It's just how it is. I'm just happy it's not stripped, that's all. Okay, this is the bolt that's that 5mm front and 5mm back. It's the only bolt out of all these 4 chainring bolts that is like that. It's weird. That's how it is. Okay, so now that everything's, all the chainring bolts are in, we're gonna start tightening. What I'm gonna do is just moderately tighten all 4 bolts, and then I'm gonna do a final tighten, and that's how I like to get even pressure throughout. You can do a star pattern, well, on a 4 bolt that'd just be a cross, so you'd go this one and then go 180 degree to the other bolt. That's directly opposite of this one, and but you know what, I don't see the need to, because it's not going to be very high torque, and when you do torque it down, it's typically printed on the crank arm, the torque specs for that center nut that we're going to install later on for the non-drive side crank arm. The torque setting is usually printed on the crank arm, and also for these nuts, it's generally printed on the crank arm as well. So we're ready to tighten. This is going to be our final tighten here. I'm just going to go around and tighten each one. I'm not going to necessarily go in a star pattern or a cross pattern. That's usually reserved for a little bit higher torque bolts. These ones are all aluminum, so it's not going to be very tight. So you want to torque these down to the specified torque, so then you don't strip them. That's probably the worst thing you can do is strip these. Torx bolts are generally known for high torque design bolts, where you're bolting together two parts under high torque, which is like 100 foot-pounds or more. This is going to be low. It's all aluminum. It's not what I'd consider a critical component that we're trying to keep in place here. So it's not going to be too high of a torque. So that's how it is, and that's it. That's our finished crank set with a new middle chainring. Pretty. So we're just gonna install it exactly how we took it out. Doesn't take much force to put in. Just make sure it's not going to be binding on anything. That's give it a couple of turns back and forth. Make sure there's no grinding and no interference, which there isn't. So we're going to install the non-drive side crank arm, exactly opposite of how we took it off. So turn the crank arm 180 degrees, put the non-drive side crank arm on, and what we're going to do here is we're going to tighten this middle crank arm bolt. That's going to apply the pressure, the proper pressure to the bottom bracket to squeeze this arm in, so then there's not going to be that play. The torque specs are printed on the crank arm right there. You can see it just glinting in the sun, but it's there. So just a moderate turn to the specified torque, and then if it's too much, you can back it out like I'm doing here until you feel a nice free rotation. Yep, feels good to me. So put the chain back on so then it doesn't grind, and then we can see how it feels when we move back and forth, and just lightly loosen it a little bit more, and that feels good to me. So I'm gonna start tightening it down. It's gonna just be tightening one side to a moderate pressure, and then go to the other side and tighten moderately as well, and then turn it back over and go ahead and tighten it to specified torque. And then once those are tightened, you want to snug that center crank arm bolt so that it doesn't vibrate loose. It's a good idea to throw some Loctite, some medium compound Loctite on that center bolt as well, so that it doesn't go vibrating out down the road. That sucks to lose that. So just snug that in. It's not gonna tighten anymore and cause any kind of binding, because those two 5mm crank arm pinch bolts are already tight on there. So try out the shifting, and it seems to be shifting fine. If it is not, then just go ahead and turn the knurl knobs on the shifters or on the back of the derailleur or front derailleur. It's not going to have a knurl knob on the front derailleur, but you're going to just use the knurl knob on the shifter on the handlebar to give it micro adjustments. If not, you'd just loosen up the cable and do some major adjustments that way. And this is the bad chainring. Clearly you can see the teeth missing again. This is going to cause you to slip when you climb. It's going to feel like you're snapping chains, but you look down and your chain's still there. It's most likely going to be this worn out, rounded off teeth. I'd say 5 years of hard climbing is taking its toll, and can't say it's from shoddy material, because after 5 years of hard grinding, yeah, it should wear out like this. But it's pretty smooth. It's amazing how much metal to metal contact wears aluminum down. Those are some of the good teeth. Yeah, some of the bad teeth there. Alright, well, that's it. Thanks for watching.